Hello children, welcome to Vidyalakshmi YouTube channel. This is your Shaktivel Max teacher. Today we are going to see chapter number 1, relation and functions, example 5 and 6. Already I have uploaded 2 videos based on that reflexive, symmetry, transitive introduction videos, and example 1 to 4 I have uploaded already. Kindly just go and check it. Now this is third portion we are going to start. See, this is example number 5. We are going to continue here. Example 5 shows what we will see. Show that relation R in a set Z. Then set is given that integer. Set is given that what actually integer. Integer means it contains negative number, positive number and 0. Okay, it contains negative, positive and 0. Then Z in the sense we know that it has negative 1, 0, plus 1, it's going on. These things we have. Understand? Right. Given by, R is given very clearly here. R is given very clearly. This is the R. So what is the R here? A comma B such that 2 divides A minus B. Means when you subtract the 2 term which is in the relation, when you subtract that subtraction should be divisible by the number 2. That is the given condition. Okay. Then we have to show that is an equivalence relation. Equivalence relation in the sense it must satisfy the reflexive and symmetric and transitive. Okay, all these 3 conditions should be satisfied. Then only we can say that R is a equivalence relation. Okay, right. One by one we'll check. First R I'll write R is equal to A comma B such that 2 divides A minus B. 2 divides A minus B. Means these 2 terms when you subtract, it should be divisible by 2. Divisible by 2 means what? This to be even number. This to be what actually? Even number. Then only it will divisible by 2. Understand? Right, fine. Now we'll start. The first topic, I'm going to take that reflexive. So first topic, I'm taking that reflexive. Reflexive means, have you remember children? Reflexive in the sense, see if same term should be there in a relation R for all A belongs to the set A. But instead of A for us integer, don't forget. Instead of A for is integer. But this is formula, so I'm writing as a. Okay. But when you go here, it for all A belongs to Z you should write. Because Z is given, means integer is given. Right. So this will continue now. What is that? If A comma A is a belongs to R, what it mean actually? Whether it will belongs to R? Yes, surely it will belongs to R. How? When I subtract, since how it will be belongs to R? Since A minus A, I am getting 0. 0 will be divisible by 2. Yes, surely it will divisible by 2. That is what I am telling. Okay, so you write, since A minus A is, means we have to subtract this. When I subtract first term and second term, it should be divisible by 2. Okay, when I subtract A comma A, I am getting 0. So 0 is divisible by 2. 0 is divisible by 2, so not an issue, it will be reflexive. Then R is reflexive. Okay, then R is reflexive. That's it. Next, we'll go to the the second topic, symmetric. Second is what? Symmetric. Symmetric means what? Have you remember? 2 term we have to take. One A comma B. One is A, another one is B. This must be belongs to the relation R. So what do you want to get? The reverse portion also should be there in a R you want to get. The reverse portion is what? B comma A also should be belongs to R you want to get. Here for all A comma B belongs to what, my dear? A. Understand? Now let's go for the checking this. Okay. Now listen. First I am taking A comma B. What is that? A comma B belongs to R. This is if condition. We have to assume that this is belongs to R. Next to what? What is meaning of this? That is That is the meaning of this line. Meaning of this line. That is a minus b is divisible by 2. Okay, divisible by 2. That is the meaning. When you divide this, it's divisible by 2. Understand? That means a minus b is what? Even number. Then only it will divisible by 2. Okay, right. So this you can rewrite that. For example, a is a 2 and b is a, for example, b is a 4 or 6 something. When you subtract this, what you will be getting? When you subtract minus 4 will be even number. Even number surely will divisible by 2. Understand? Surely will divisible by 2. We understand? Like that, suppose if you change this, 6 minus 2 if you change, the order if you change, then what I am getting? Plus 4. Plus 4 also will be divisible by 2. That is also one of the even. Same manner, a comma b in the sense a minus b I am getting. If a minus b is divisible by 2, then what is the meaning actually? This you can write, even b minus a is also divisible by 2. Am I right? If you change the order, it never that subtraction will be given either positive or negative. But the outcome is what? Even. Even number will be divisible by 2. So b minus a also divisible by 2 because b minus a is what? Even number. So this how you can write b minus a is divisible by 2 in the sense surely it will be in the relation R. So this you can write that b comma a is belongs to R. So what is the actually formula? A comma b belongs to R. Output if we get b comma a belongs to R, then we can say it's a symmetric. So I assumed a comma b belongs to R. What is my output? B comma a belongs to R. So what you can say here? Therefore R is symmetric you can say. R is symmetric you can say. Okay, one we have done. Sorry, two things we have done. Next we will go to the transitive. What is transitive? We will go. Okay, transitive we have to check. Third point is what? Transitive. If it is satisfied this also, then only we can say this is a equivalence relation. Okay. So first you take if a comma b and b comma c both belongs to R. Both belongs to R. This implies except the common one b and b, what is that? First one of this, last one of this, a comma c also belongs to R, you should get. Here for all a, b, c belongs to the A. Okay, A. This is the formula should satisfy for this transitive. Now let's check this answer. First I'm taking the two things will be belongs to R. A comma b and b comma c is a belongs to R. What is the meaning of belongs to R? Both belongs to R. What is the meaning? Subtraction of AB is a even. Subtraction of BC also even. Then only it will divisible by 2. Then I am writing the meaning of this. A minus B and B minus C is are divisible by 2 is the meaning. Sir, both are divisible by 2. What is the meaning? A minus B is a even. B minus C also even. Both the even, when you add, what you will be getting? Addition of two even number is a even. Am I right? That is I'm going to do here. Okay, then add these two. What I'm getting? A minus B add B minus C. Then minus B plus B will cancel. Then what is my output? I'm getting A minus C. See, I told you that this also will be even. This also will be even, I said. So you write here, this is even number. This is even number. Why this is a even? Why this is a sum of two even number is even? Because A minus C, I said that. A minus C, I said that even. A minus B is a even. Even B minus C also even. Then, since you write sum of two even numbers is also even. Sum of two even number is also even. By using that result, A minus C also even number. A minus C is a even number. then what it mean? A comma C is belongs to R. It mean A minus C should be divisible by 2. Then only, or else I'll write one more line. A minus C is a even, that is A minus C is divisible by 2 is a meaning. That is what you can write, that A comma C belongs to R. See, as per the formula we got it. First 2 I assumed in the R. Output I got A comma C also belongs to R. Therefore what you can say, R is transitive, you can say. R is transitive. So it's satisfied that R is a reflexive, R is a symmetric, R is a transitive. Therefore, what you can say, R is equivalence relation, you can say. What you can say, R is equivalence relation, you can say. That's it. Have you understand? That is, they asked to prove, we have done. Understand, children? That's it. You take a note, we'll go to the next question. Okay, we are going to the sixth one. Sixth one says, what you just see? Sixth one says that let R be the relation defined in the set. Set is given, set A is given here. Set A is given, that you write. What is set A? Set A is given that 1, 2, 3, 4, 5, 6, 7. This is our set A. See, answer starts from here. Okay, answer starts from here. In the previous question, set is given as an integer, but here it's given that 1 to 7. Understand? 1 to 7. By relation also given. Relation R is given by what? A comma B is a relation R in the sense it should satisfy both A and B, either odd number or even number. A and B, either A is odd, then B also should be odd. Or A is a even, then B also should be even. That is the meaning here, nothing. Understand? That is they are telling. Both A and B. Both A and B are either odd number, either odd or even. That is the question given. It means what actually? For example, I'll give some few things alone. I'll give if the relation is going A to A. Actually, this is always A to A generally. So A to A, if it is going, 1 is going to 1. So you can write 1 comma 1. 1 is going to 2. 1 comma 2. So 1 comma 2 will not come because 1 is odd, 2 is a even. So this 1 comma 2 will not come in the what is that? R. That you have to remove. Then 1 should go only with the odd number. 1 comma 3, 1 comma 5, then 1 comma 7. That is the meaning I'm telling. If I'm taking first number is odd, second number also should be odd. Like that. Okay. Same manner, if I'm taking number 3, 3 will be going to where? 1. Okay. 3 will be going to 5. 3 will be going to 7. This is the meaning. Both should be odd. If I'm taking 5, 5 should goes to 1, 5 should goes to 3, 5 goes to 7. That's it. This matches should be formed. Or else 7, if I take 7 should be 1, or 7 comma 3, or 7 comma what is that 5. Like that, same number also you can see 7, 7, like that 3, 3, like that 5, 5. This also will be a even number, right? Sorry, odd number, right? This also with the odd number you can form. Same manner, you can go to what actually? Even number. 2 if you take, 2 comma 2 will go, 2 comma 4 will go, 2 to 4, 2 to 6. Then 2 to 6 also will go. Same manner for 4, for 6. Okay, it will be going on. It will be going on till even number 6 comma 6. I wrote 7 comma 7. Okay, it will be going on like that. It will be coming many. Understand? But the thing is what? First what you are taking, it should be like a odd means odd, second also. First even, second also even. That is the condition is given in a question. Okay. Then what they are telling, show that R is an equivalence relation. Later something they are telling that we'll see. First we will prove R is an equivalence relation. Okay. First we will prove that R is a equivalence relation. First we will prove R is a equivalence. Equivalence means what do you know? Reflexive, symmetric and transitive. These three conditions should be satisfied. Okay. First I am taking that reflexive. So if I am taking a reflexive, what is the formula says? If A comma A belongs to R, for all A belongs to A. This is the meaning. Means whatever the element, the same number you're taking in a how many terms, how many elements you have, for all the same term should be in a R. It means 1 is there, then 1 comma 1 should be there. Understand? Next to 2 is there, 2 comma 2 should be there. Next to 3 is there, means 3 comma 3 should be there. Next 4 means 4 comma 4. 5, it will form because 4 comma 4 is even to even. 5 comma 5 odd to odd. 6 comma 6 even to even. So everything will be there. So that if A comma A is belongs to R, for all what actually, this belongs to R, since what actually, if A is odd, first A is odd, even second also what? Odd. If A is odd, R even, it will be satisfied. First is a A, odd, then second also what? Odd. First is the even, then second also what? Even. So not a issue. So this will be satisfying. Therefore, R is what actually? Reflexive. R is what? Reflexive. Second I am going. Second is what? Second is symmetric, we have to check. Second is symmetric. Symmetric will check. Symmetric condition is what actually? A comma B if you take belongs to R. The reverse portion B comma A also should be belongs to R. For all A comma B belongs to A. That's it. This is the condition should be satisfied. Understand? So let's go to check this. Right. Now if I take that A comma B belongs to R, what is the meaning of this line? Either A is the odd, then B also odd. Suppose A is the even, then B also even. That is the meaning. That is A and comma, A and or comma, A and B are odd number or even number. This is the meaning. Okay. Now, if I am changing this B comma A, what will happen? Then also, suppose A is a 1 or a 3. If I change, it never change. 3 comma 1. 3 comma 1 also what? These are odd, that is also odd. Not an issue. So this is not an issue. So this also then belongs to R. Then also it doesn't change the meaning. Then therefore R is symmetric. Okay, R is symmetric. Very easily you can go these things. Okay, very easily you can go this thing. Next, third is what? Transitive. Third is what? Transitive. Transitive means we know 3 term you have to take. If A comma B and B comma C belongs to R, this implies A comma C should be belongs to R. These two you have to take in R. Output, what you have to get? Common term B is there, right? Except that first of this, last of that should be there in R. That's it. That should be satisfied. Understand? That is the answer. And for all A comma B comma C belongs to A. That you don't forget. This is the formula says. Now we'll go to the answer. See, suppose if I'm taking A comma B and B comma C belongs to R, what is the meaning of this line, children? That is it's satisfying A is odd, B is odd. So, suppose B I'm taking odd, the continue also will be what? Odd. It means, listen carefully here, or else I will take this. Suppose A, if I'm taking a 3, B also what? Should be odd. Odd means what? Either 7 or 5 or 1. Like that, B is a 7 here, then here also B is what? 7. Okay. If it is a 7, C should be odd number. Odd number either can be 5, 1 or something. The thing is what? All the 3 are what? Odd number. That is A, B, C are odd number or even number. It can be odd or even. That is the question says. The things which you assumed, that is the meaning. So, if all the 3 number are odd in the sense, If I choose first one and last one, if I choose, that is also what? Should be odd number. Then this also will be belongs to R. Am I right? A is an odd number, C is an odd number, means surely it will be in the relation R. Because they said either first two will be odd or both are even. That's not an issue. Here I am taking like this. Just example, I said 7 1. Don't think it will be like same. Just for explanation. So it means what? It means what? R is transitive. So if R is a transitive, what is the meaning, children? R is a reflexive, R is a symmetric, R is a transitive means, what is the meaning, children? What is the meaning? It satisfied that R is equivalence relation. R is equivalence relation is a meaning. That is they asked to show. They asked to show that R is a equivalence relation. Now it's done. First part is done. Second, what they are telling, show that all elements of subset of 1, 3, 5, 7 are related to each other. Surely it will be related to each other only. The reason is what? All the numbers are what? Odd number. Odd number will be related to odd only. So it's not an issue. I will use this place. Just a minute. I will use this place. Here onwards. This is let it be. I'm not disturbing this line. Here I will write this. Okay. Here I will write. So what is the meaning? 1, 3, 5, 7 are related to each other. You write as it is, each other. Why? Since all are odd number. All are what, my dear? Odd number. All the numbers are odd number. Odd number is what is that? Going for the relation odd. 1 is going to odd. Like that 7 is going to odd. 5 also going to odd. So all the odd number is relating to odd number. So then it is true only. Next line. Next line says what? And all elements of subset of what is there? 2, 4, 6 are related to each other. Yes, that is also true. Okay, that is also what happened? True only. Next line, I will continue. Next line. What is that? 2, 4, 6 are related to each other. Related to each other. Okay? Related to each other. Why? Since all of them are even number. See, this is even. Even is going for the relation what? Even. See, if I am taking a 2, 2 is going to even number. 2 is going to even number. 2 going to even number. So, even number will be related to even number. So, that 2, 4, 6 surely related to each other. It never go any other number. 2 never go to 1. Because 2 is the even, 1 is odd. The relation is not defined like that. Both should be odd or even. So 4 never go to 5. So it will be related to the same number only. It never go to other number. That is the meaning. Okay. Next line what they are telling? But no element of 1, 3, 5, 7 are related to 2, 4, 6. That we know. Because 1, 3, 5, 7 is an odd number. 2, 4, 6 is an even number. How odd number can go for relation to the even number? Definition is what? The given thing is what? Both should be either odd or even. This is an odd number. Next one is an even number. Cannot go relation. That is you have to write as an explanation. Okay. That is you have to write. So that no element of 1, 3, 5, 7 are related to 2, 4, 6 since one is odd, other is even. Okay. Okay, since I will use this place. Okay. Alright, fine. So next word are related to since. Since what? 2, 4, 6 is even. 1, 3, 5, 7 is odd. So even and odd never relate each other. It should be both are even or both are odd. One is odd, other is even, it never relate. That is the meaning they says. Understand? That's it, children. Ends proved. I hope you people have taken the notes properly because I have erased here. Okay, thank you, children. I will come to next video with exercise sums. We have seen at present the 6 example sums. Introduction of reflexive, symmetric, transitive. These things and all I have uploaded in 3 videos, including introduction and exam till example 6. I uploaded in a 3 video. Kindly go and check, children. Thank you. Take a bye. If you like this video, kindly share to your friends also. Take a bye.